Hello.
Yes,
Morning.
we are live. Morning. I don't know what is the topic for today. Uh, was it some planning session or what was it?
I don't know. I like planning is may not be useful or not really enjoyable. So it may be more about a maybe the approach for this year. Perhaps what we intend to achieve. Okay. Well, and it can be as Venkat maybe kind of suggested that it can be whatever one wants to do, basically, right?
Yeah. Well, we have to converge at some point. I don't know. Uh,
But the thing is that for me, the very original appeal of the group was that a basically to collaborate with a specialist from other disciplines. So especially for me, most of my time is spent on AI, whatever that means today, and software. I do have some skills on electronics and a bit of PCB stuff like that, but that's it. After for 3D modeling, CAD, and so on, I haven't done that for 4 decades, basically. Okay, so working with people who who can complement the skills toward building something like a space rover, where we come from, right? But so for me, it's super appealing. Okay? But we don't do that anymore. Okay, so now this is a garage. Okay, it's all fine. Okay, just wondering whether it's explicitly what we expect and what we want to do. Okay, also what to expect from that. Okay, because last year, especially around the Yakozo and the mini app. Okay, so we do have some achievements, but for example, mini apps are gone basically. Okay, and and I don't feel like we have a common project basically based on that.
well,
Okay,
I know what I'm doing. I'm building a space rover. I don't know, but
Well, yeah,
I'm crawling so slowly that no movement might be visible,
It's
and
because
like
your battery.
enabled, yeah, enabled with crypto rails. That is, I know exactly what I want to do. Like I could do this really fast, but like I cannot dedicate the whole time. So actually, the entire architecture is there in my head. What I want to do, electronics wise, crypto rails wise, like whatever the agent or related to the rover needs to be done. So basically, like a lot of things are there in my head, but maybe I'm crawling too slowly for any movement to be visible.
but the thing that then it's more like you do something and we're the audience. Okay, which
Yeah.
is fine. Okay, which can be actually a show. Okay, we could turn this weekly meeting as a show, and I think that's great. Okay, but an alternative, okay, is really to have a skill complementarity. Okay, so I think perhaps I've done more software than you. Okay, and so I do some contributions, but it's not like basically I'm just redoing what you've done. Okay, so I moved from Frames V1 to Frames V2 for the mini app, and that's
Yeah.
about it, right? Okay, so I wonder whether it's if it's satisfactory and we feel it's good and learning and so on. For me, it's great. I
Uh,
like this. Okay.
yeah. Well, I think it should be possible to find some sort of uh, common things to work around, right? So we know how we do have a vision of what we want to do, but it's just that I think like we are so slow that we are not able to or at least see the convergence.
Mhm.
So basically, like if we would be doing this full time, we would be seeing the convergence or like movement much more, right? So this is what like I do in my evenings or on my weekends,
I
and
don't know.
a lot of the current work was basically what I did on Christmas holidays.
Mhm.
Yeah.
But see, for me, I don't know about that because I can spend a lot of time doing nothing, into quotes. So doing something but not toward a moving target, basically, because I'm learning and stuff like that. Okay, and that's fine. Okay, and I think that's what we've been doing for some time now. Okay? But I think it's very different from when we have a common goal, and then all of us we cannot be full time, most likely, but we can still spend 1 hour here, 1 hour there toward that common goal. And then over time, over a few weeks, we see progress. Okay, because we
Yeah.
have that.
So basically, like, what was that Moonbot project?
Mhm.
So that is the kind of thing I want to build, but with Tumblr and crypto rails. But we don't have that much budget. But like, I could see myself building that full time if I had the money.
Ah, yeah, that's a cool
Yeah,
project. And so
yeah,
here,
yeah.
so you look at this, based on that, what I'm trying to do is basically to mash up these
And
two things. Okay, Tumblr, we have it, and this is from a maker
I
called.
think that if we want to get somewhere, so just put some,
So sorry, you were saying, Mayor? I couldn't hear
put
you.
one on top of the other.
No, okay, kind of. Okay, it's more like to take the Tumblr we all have, and to take, but we are budget constrained.
Yeah,
Okay, so for the project, this costs maybe $50. Okay, without the Raspberry Pi, but this is acrylic. Okay, the whole thing is acrylic, and you assemble it. Okay, it's a kit, so you get the acrylic body and the sensors and the motors. Okay, and you see it's a four degrees of freedom. I don't want to force it too much, but the hand can open and also can turn. Okay, so you have 4 degrees of freedom here. The point is that it's
Anurag,
super.
can you make Eric's screen
yeah.
the full screen? It's hard to see.
Yeah.
Thank you. I haven't thought of that. Fortunately, some people have a brain. Okay, so the thing that you see is acrylic. Okay, very light. Okay, so basically most of
Yep.
the weight of the Raspberry Pi that is inside. Okay, that we put inside. After you have a Raspberry Pi camera and the typical sensors. Okay, and so the thing that the arm
Yeah.
itself, you see, it's plugged on it, so we can just pull it out. Okay, and so the idea is to take this arm and to put it on another acrylic here. Okay, so there is
Yeah.
some problem on how to assemble. Okay, maybe putting the battery somewhere else or. Yeah. So the point is that this arm is very light. So perhaps you remember a few months ago, Venkatesh presented a ChatGPT discussion about the inverse pendulum. Okay, so the basic one, and after several evolutions, more complex models of it. Okay, and so everything depends on the weight of the different parts and so on. Okay, so here I'm not really making any bets, but this arm weight is super negligible compared to the weight of this. Okay, and so I wonder that doing this and doing some basic checks of the mathematics based on Venkatesh notebook with ChatGPT, basically try to do what we were talking about a few weeks ago. Okay, so to have this arm on top of the tumbler. Okay, and so of course make it work. So meaning that probably modify the code, depending on the mathematics, modify the code so the movement are compensated. Okay, so this is what I'm trying to do these days. So aside the simulation work on Weebot that we've seen last year. And so there is a link to Moonboat, perhaps, that this could be, this could be, yeah. I think it's a far-fetched here, but it's putting pieces together. Okay, but here manually mainly. Okay? To do it like in Moonboat is way more work, but this could be a piece of it. Yeah.
But what Alien had some software, right? Of
That is one of our goals.
yeah, multi-robot cooperation. Exactly, like using a single interface to control multiple robots, right? So
So
he had open source something. I
Mhm.
didn't have time to check it completely.
it's just to translate movements from one body to another, basically.
Hmm.
And I guess it works in simulation, but that's on the real robots, huh?
So
Yeah.
the thought that's been bothering me for the last few months is everything is moving so fast uh, that anything we think of doing, somebody does it better, bigger, faster, and 3 years before we do. Even if we think we thought of it among the earliest groups. Uh, so yes, it's maybe satisfying to, like, I don't know, take the Moonbot's open source code and put it on the Tumblr, or do these other things. Like, we talked about an arm on a robot like this and doing the balancing problem. Last month, I saw at least 3 prototypes that had already done that, right? So the problem, it's not a problem per se, but the reason I think I'm sort of resisting thinking in terms of goals is any obvious goal we think of, somebody else is probably already doing it, like I said, bigger, faster, better at like 10x the budget. So I think a better starting point than starting from a goal and working backwards is to start with almost a white space map of what are the obvious things that a lot of people are doing, because once you think of the idea, it's mainly a matter of like resources, time, and just putting in the effort, right? Versus what are the non-obvious things that nobody's working on, where if we work on it, even if we are moving very slowly, when it is done, it'll be a contribution. So that's why I was very excited when Anuraj thought of the cryptobotics thing a couple of years ago, because at that time nobody was doing it, and it's still our experiment was one of the first. And even now, it's sort of like underdone. Like there's maybe 1 or 2 other groups, but it's not. That's an area where you can move at our pace and still make a contribution. Um, though I think, like you said, the mini app, it was like 1 step forward, 2 steps back because of forecaster problems. So we need to find an angle to work where we can work at our pace, don't have dependencies that can like pull the rug from under us randomly, and also has a chance of making a contribution if we succeed. So I think the two things I've heard in the last year that seem to have some of that element of like underexplored white space. One is the kind of like ad hoc network angle, which is like, what happens if you have multiple modules with multiple little processors that are networked together and can very flexibly be composed. So not just mechanical or electrical composability, but like, logical wireless composability. So that's one potential idea we can take as a starting point, not as a goal, but just an idea to start from. The other one is the one we've been working on for several years now, actually, the VPN teleoperation type thing. And again, I think very few people are actually pushing that vector. And anytime we talk to people or people do commentary, they keep saying secure teleoperation is a very hard problem and nobody has solved it. So those are my two ideas. Maybe we can brainstorm a few more and see, are there interesting goals we can sort of like target along those vectors. So what's an interesting goal with local ad hoc networking? What's an interesting goal with teleoperation? So are there some other ideas like that or starting points?
Well, regarding the teleoperation, so I have a kind of a chat discussion with Claude of the architecture of how a planet scale auto discovery of capabilities of the robots and VPN could be done. So the architecture is kind of done. It's just implementation stuff. So that is something I've not seen anywhere. It's like a planet scale auto discovery with Zeno. And the problem with cryptobotics is like the people in crypto have like not much background in robotics, and the robotics people are not much interested in crypto as infrastructure. So you would see very less people in both.
And also, to be honest, the crypto angle, even though it's novel and unusual, it feels like an add-on. It's not fundamental. Like you can do a lot of interesting robots without adding that crypto element. Be it might be critical a couple of generations from now, but right now it feels like an optional extra type feature. Whereas teleoperation and ad hoc networking both feel like essential features for the next step. Like Meyer already pointed out that the home might be littered with multiple robots that are causing chaos. So already we are seeing a clear need for that problem. Teleoperation, I think, is already kind of a problem. I don't know how all the people putting the sexy demos on X are actually doing it, but I suspect most of them are uh, vertically integrated, basic local Wi-Fi kind of stuff. They're not truly thinking the problem through. So I think both of them. So I think, yeah, planet scale discovery is one way to state the goal, and I think we could sharpen it a little bit more. So the kinds of things we were talking about of can we keep it very, how do I put it, capture resistant and decentralized, by which I mean if I have two robots in my house, they should be able to talk to each other without talking to Google, and then that eliminates Google being a trusted third party. So again, some crypto principles, but in a more abstract way. So I would say, yeah, planet scale discovery with almost a subsumption type architecture, like having the discovery happen at the lowest spatio-temporal abstraction level that will do the job, right? So you shouldn't have home level discovery go to the other end of the planet. You should have country level discovery go to your enemy country. So what is that full I don't know. Anurag, you said you've thought it through. Does your sketch
Uh,
architecture solve this problem?
Let me open the chat.
That would be good to discuss a little.
Okay, but while we discuss waiting for Anuraj to find it, I want to point out two things. Thing number one, I have a slightly different goal, and that is learning. I mean, Eric was hinting at it, but the fact that somebody built something before doesn't mean that we're not going to learn by analyzing the situation. And what we've been learning on this group, I can speak for myself, but Venkatesh, you've been very vocal as well, is a lot of things and a lot of experiences and even know-how and doing stuff that we wouldn't have otherwise. And that's one of the reasons why people join these amateur groups. It's in order to do stuff they wouldn't do otherwise and have fun while doing it. So the only question I think we should be asking is, what do we need to do to make sure it's fun? Maybe the answer is a goal. Maybe the answer is other subjects. But we don't have to be better, faster, whatever than anybody else, unless we need that in order for it to be fun. Okay.
I would say to some extent, for me, it's a necessary condition for having fun. Like, if we build a crappy two-wheel robot with an arm, and next week we see like 10 commercial Chinese models with like much better capabilities and arms that you can buy for $50, that is, to me, partly demotivating. Yes, learning is fun, and fun comes
Okay.
from learning. But yeah, for me, having, even if it's like a small 1% chance of like doing something on the frontier and contributing to the bigger trend, that's interesting. And on a more practical perspective, I mean, it's kind of how I always end up getting my consulting work, which is being on the frontier, doing enough to learn, but also learn on the frontier, not learn stuff that the professionals think of as like 10-year-old toys, right? So you kind of have
Hmm.
to learn on the edge, and then maybe you find interesting opportunities. Maybe even if I can't participate in building a moon bot, I can, I don't know, find a client in the robotics boom next year. But that's a secondary consideration. Primary consideration is for this group to have interesting stuff going on. But yeah, I don't know if Anurag just found this.
Yeah, I don't know if the screen is visible yet.
Sorry, before we switch to you, Anuraj, is that for me, I have appeal in both ways we are talking about here. Okay, so what you said, Mayer, what you said, Venkatesh, I have appeal in both. Okay, The thing is that we are talking about robotics, okay? And the thing that in my experience is that to achieve anything as simple as it is, but to achieve it really, not just making a demo, is a lot of work. Okay, so being at the edge is certainly appealing. Okay, but is going ultimately to be shallow. Okay, so I'm not sure about the impact in that case. Okay, but definitely just making. So, for example, if I achieve to put my arm on the tumbler and make it work, okay. Well, it's we can call that an achievement, but the impact is going also to be tiny, if any. Okay, so I don't know. It's I guess it's more about question of style, perhaps, in the end. Okay. I don't think that impacts the same people in the end. Okay, so sorry. Thank you, Anuraj.
Yeah, so this is kind of the planet scale discovery and VPN networking, or like VPN is not needed, but the robot fleet, auto discovery of robot fleets on a planet scale.
Can you zoom in a little bit more? Like,
Yeah.
Uh, wait.
I think I see zoom controls on the left.
You have it also shared in Discord. Okay, cool.
Yeah, that'll be helpful if this is a public link that we can see.
I can share the link, but I don't know. This window is a little slow. Click.
I really have to start using Claude more.
Can I ask a question? Is there some maybe unexplored way of using AI in order to build, let's call it demonstration robotic components?
So personally, I haven't really understood the question now.
When we're using AI, we're using it in the standard way of building code and analysis and whatever. I'm asking, is there some particular way which is better for robotics? Different way? Is there different questions we should be asking for robotics?
I mean, the question that Anuraj is addressing on the screen, I think, is a different way. We are looking at a horizontal slice of the stack that doesn't normally get much attention, so it's a different angle in some ways.
Yeah, but we're asking the LLM is not affected by the fact that it's a robot. I'm asking if maybe the right way to prompt an LLM in robotics or in some aspects of robotics
Got it.
different. I mean, it's just not what Anuraj is doing, but imagine we were talking before, now the world has gotten better, running an LLM on your Raspberry Pi or an SLM perhaps. But the point is that today we work in voice mode or we work in prompt mode. And maybe there's a different mode that's more correct for robotics, even though LLMs don't have a memory. Maybe there's a right way to prompt them when LLM is helping your robot do stuff.
So I put this on the special topics tab last time, but I think the natural model for robotics is the VLA model, the Vision Language Action models, and they're kind of like Claude Code type setups, where their context, instead of being a directory in the file system, is a kind of like a world model being built up through action and vision loops. And I think if you work in such an environment, and you ask uh, the LLM to design like at least some space-time type components, it'll it'll work differently. But that won't
Mm.
probably make that much difference with say the software or electronics layers, which for that maybe simulators are the right way to do it. Uh,
Okay.
but yeah, I'm sure these robotics optimized ways of using AI are already sort of being used. But yeah, actually, we didn't actually talk through Anuraj's
Yeah,
model
so
yet. So
basically, like, this is like the user interface layer could be anywhere on the planet, and the discovery layer is based on the ERC 8004 register. So as long as you have like uh, access to internet, you should be able to query the blockchain and then get so each, let's say, Europe or each continent or wherever, whoever wants to serve a fleet of robots spins up a server and updates the registry of the robots they have and with the capabilities, and this would be queried via the 8004 registry. And this could be like anything on the user facing thing, or the user interface could be anything. It could be like a LLM agent or a text based agent, or you could make a React uh, uh, app that manually somebody is using. So it could be like integrated with the discovery layer, and this and discovery layer is completely decentralized, and like each fleet basically could be like a different, so each robot could have like a different capabilities, and they would advertise it through MCPs, and this MCP endpoint would be in the 8004 registry. So this is like a very bird's eye view of what's there. So you could also have yeah, so basically you could have like robot capability tiers, and then you could have like different tiers of compute and what they are advertising. So right now we have only like ESP32 based hardware. So basically we could start with this, and then add the RPi based. And if somebody wants to add the Jetson based robots, they could add that too. And this is what the how the MCP discovery flow would work. So this is done with an AI agent. So like each robot could also be having a associated agent in the cloud that would be like doing uh, agentic actions on behalf of the rover, or it could also be integrated with this the commerce protocols Google and others are coming up with. So basically, like you could have endpoints, and these are like some of the functions. So cloud also gives you the skeleton implementation of what needs to be done. So these are like the each. So you could have like a reference server each. So suppose if I want to serve a fleet of robots, so I could serve the server would basically have these functions, and like each robot would register to my server, and then this is what I register to the ERC 804 registry. And yeah, so and like whenever somebody, let's say Eric, wants to control uh, my robot, so what he does is goes and finds through the 8004 registry what like European fleet I'm running, and then he gets the list of robots and the capabilities they have, and then he selects and basically like you could use the payment protocols to gate it, and then teleoperation could be direct from there. So this is like a very high level overview, and like there is also this is like a quite detailed implementation too. So I have not tried it yet, but this is like a brainstorming session I did with Claude. And yeah, so Zeno, so if you are like, if just somebody in Japan itself wants to control Eric's robots, so Zeno allows like local control. So you just query the robots Eric has, and then like Zeno allows basically local, uh, it's a peer-to-peer networking. Yeah. So this was like a,
so you use 8004 to find the MCP endpoint, and is that
yeah,
static and stable? And once you know it, it can be kind of a social network of robots that are friends with each other, or humans and robots that are friends, and They don't have to go back to
Yeah.
the 8044
So I had,
whatever.
I think I had some discussion about like what to store in the 804 registry on the IPFS, and what should be mutable. Because like let's say the IP keeps on changing, or some additional capabilities are added to the rover. So I think Claude suggested to keep some things on. So the IPFS points to some endpoint where something could be looked up. Where is it? Yeah, so this is what. So it could have like an ID and the wallet info, and where the information is, and basically the off chain, it would point to an off chain registration file, which could be updated. So on the registry file, which is immutable, you store the URL of where the registration file is, and this is what we can update. So basically, if Eric keeps on adding capabilities to his robot, so he just updates once after registration, he just updates this file.
Got it.
And yeah,
So that's
so I'll share this.
Can
I
I
think I've shared
can I
some of the.
focus
Yeah, yeah.
on one little part of this system, and that is learning. How do I get my robot to learn from what Eric's robot has been doing for Anuraj in the past 6 months?
Well, you could just add like the activity stream endpoint, or yeah, like the registration file could have a activity stream JSON file, which could, like, whenever the robot does something, and since you know the IPFS URL, you could just find out like the what activity Eric robot has done. So you could query it from there.
But I'm not learning. In other words, what you have here is a system which connects all the robots together, allows them to find each other, allows me to find them. But
Yeah.
how do I get learning from them rather than only action?
I think this fits within since it's an MCP endpoint, the capabilities you can expose don't just have to be like, agentic capabilities like move forward or backwards. They can also be like, intelligent memory capabilities. Like, you could query the MCP endpoint for give me a dump of all the missions you ran in the last 10 months where you went searching for an object, and then you get a data dump of like search mission profiles, and then you can do some learning with that data. So think of I would say we should think of the MCP endpoint as being a general kind of like query interface, not just uh, discovery of like software capabilities. In a general sense, like retrieving memory is a software capability, right? And memory of your own actions is learning data that can be shared.
Hmm.
So yeah, I think it fits within the paradigm reasonably well. And this can be offered by some robots that want to make their learning histories open source and public. Other robots may not be willing to do that, and they will simply say, I don't offer my memory as learning data.
During the last, like the cryptobotics protocol white paper protocol listing call, we were discussing something about a layered, uh, um, like a layered structure for the different protocols we'd be using. So this table kind of on a high level tracks it. So like, yeah, for discovery we use 8004, and then the AI interface is MCP. The payment is X04. The transport layer is Xeno underlying, and below it is just TCP/IP. Fast tele operation, like once the discovery has been made, you could do it with WebSockets. So since it's a two-way.
So I think these details should be kind of considered the compiled target. Like once we have an idea of how a robotic agent should model itself and sort of present its self model to the world, then you ask the question, okay, that's the abstract model. how do we compile it into this set of like existing protocols like 804, 402, and all the others, right? So I think the upstream question to ask is, if you have a robot, how should you just describe it in abstract terms? So there's a couple of different approaches, right? Like one, I think, which you kind of are pointing at here is you kind of just describe your bill of materials. You say, I have an ESP32 processor, I have 2 drive motors, I have 3 stepper motors. That's one way to describe it. Another way to describe it is to say, don't worry about my physical structure at all. What I can do is be present at an X comma Y location and look in any direction and send a picture. And the person doing the teleoperation may not care whether it's a spider bot or a two-wheel tumbler or whatever. All they want is the capability to take photos in a particular direction, right? So that's kind of like a use case way of describing an agent. There might be a third way, which is like, just history. Maybe you don't explicitly say anything at all about what you can do in any way, but you just provide your entire history and say, on January 1st, 2026, I went running around and took soil samples. And from that, you can infer that this is a robot that's capable of moving spatially and capable of taking soil samples, right? So then this is sort of an implicit model that you can learn on. And this actually makes it weirdly flexible because you can completely replace the robot with a different robot. And so long as the history is continuous, the other end may not even know, right? It can be like a ship of Theseus endpoint where parts get swapped out without it being completely apparent. So I think that's the obvious next question to ask. All right, this is the compiled target. What should the model description be? Like, take the thing Eric is building now, a tumbler stacked with an 4 degree of freedom arm. What are the 3 or 4 different ways it could be described within an 8004 syntax or grammar, right?
Yeah.
Can we
So
just focus
go
on
on.
that question? Excuse me a second, Anurag. That sounds a bit like a protocol question, but what is the best way to describe your capabilities? Okay, that's really the question, isn't it? If you're a robot, what is a internationally accepted way of describing your capabilities so that other robots can identify it as well?
Other robots and human operators. So here I think it would be useful to look at like existing protocols, right? When you call an Uber, you don't really care what type of car shows up or what type of engine it has. You care about the number of seats and whether it can take you from point A to point B and whether or not there is surge pricing, right? So that's kind of the way to go at it. Like, keep it as abstract as possible. So that means, yes, you can have details like ESP32 available for querying for um, teleop use cases which require that. Like, maybe I'm a teleoperator who has a fragment of code for ESP32 that I want to try and run on the remote point. In that case, I need to know whether or not there's an ESP32. But if all I want is, can you go take a photo in a particular direction? I don't care if it's an ESP32 or RPI or some other hardware, right? So
Yeah, but it depends on like this who the user would be, right? If it's a builder type, coder type, then like they would require more details. But if it's like just a normal user, then they would be working at a higher abstraction level or querying at a higher abstraction.
So maybe you need multiple models. So you ask a query as in send directory entry as retail user, or send builder verbose directory entry,
Yeah.
something like that.
Yeah, so it kind of suggested something like this. So like a different user might be asking different queries, but this is in terms of AI agents, but like a user is also kind of an agent.
So the 804 registry format is like very generic, right? You can
Yeah.
basically, if I wanted to, could I just do like a free form text description of my robot and put that as one big text blob field? And
Probably.
then,
Yeah.
yeah,
So basically you store something on IPFS and then you could point to it.
because I think it would be interesting to try and make the introspection and discovery output as natural language as possible, and then let the intelligence on the other end do the inference on what the plain text simply means, right? So maybe the way I would describe my tumbler in plain text is, hey, this is the Elegoo tumbler standard, but we've modified it with ESP32. It has a camera, right? All this written in natural language. And on the other end, they kind of use that text block to infer that it can probably accept forward, backward, right, left commands.
Well, it doesn't have to be text, right? Like once you provide a standard, let's say a Python script, you write it in, you fill some fields, and then it will generate the ERC registry for you. Does it have to be natural language, or
Yeah,
does it?
I'm just using that as an example to
Yeah.
point out that we don't necessarily have to think in terms of extremely controlled vocabularies and like very precisely defined ontologies and stuff. It can be much looser.
Yeah. So I'll share this chat with you guys. You could like
Mhm.
have. I don't know if Claude allows forking this chat, but yeah.
You've shared the content on
Yeah.
Discord.
So I shared these ASCII diagrams.
Ah, yeah, yeah.
Yeah. Um, what else was there? Yeah. So here the teleoperator, but
What do we need to do here to try to test that? So, for example, we make a simple library that implement that, and we install it on Marius robot and Venkat's robot and my robot, and we do a session where Anuraj tries to discover what is available and to take over control of one of the robots, something like that.
uh, well, if we want Gene, well, technically I know what to do, but like with the current, so our Tumblr is running on HTTP, so we will have to use that Geno Pico, uh, and then expose it as topics on Geno, and then we need like a cloud server, and then a local server for you, and then somebody also has to do the 8004 registry Python script. So there is something called chaos chain. I think I posted the link. So
Yeah.
they provide they provide an SDK for doing the ERC 8004 activities. So we could just use their SDK to and then like we have this YaRG fast API backend, right? So we could basically integrate some sort of user interface for that. So basically, you go and see, ask what kind of robots in Japan Eric is running. So after that, like we could have some sort of test. It requires a lot of implementation, but yeah, like kind of technically we know what we need to do. Might be just slow. So yeah, and then we also have to expose the ESP32 like affordances to either Xeno or like uh, something else.
Mhm.
Uh, Maybe the first part would be like we can integrate Xeno later on. Maybe somebody could study the chaos scene SDK and how to do the 8004 registry.
Right.
And then basically we have like 4 HTTP endpoints, right? So we could have like a registration file which lists those HTTP endpoints with the IP. And then you could use that SDK to register the 8004 and to find out uh, what kind of robots I am running and what are the endpoints.
Mhm.
And once that is done, basically we could get somewhere from there.
Would it be interesting to start first on software only, in the sense that you see, for example, for the Tumblr, we have this fake rover script.
Yeah,
Okay,
yeah.
so basically it's a just software that runs. Okay, and it exposes an API like the Yakozo. Okay, and after it's faking, sending pictures and whatever when it's queried. And it would be perhaps interesting to make a small simulator okay, where we have a bunch of these fake rovers that pretend to be somewhere in the world,
Yeah,
and
so
and that layer, that the whole layer in protocol run over these different items, because we could do that on a single computer basically, and that would
yeah,
be
so basically that you we could simulate a rover with HTTP endpoints, simulating the ESP32 endpoints, and try the registry with that. So that would be like a small step forward.
for me. What is interesting is that if we have some UI and visuals, that allows us to discuss during a meeting, it would be more about like how useful it is as it is, what can be changed, what can be added, and so on. A quick feedback loop, basically.
Uh, yeah, so I also have this React app, right? So where is it? So this Tumblr React web app, it's on our YaRG Robotics Garage. So it's basically like just a React app. You can so this doesn't do anything else other than local Wi-Fi control. So it will give you similar UI what I have for the but without like the fast API backend. So this is
Mhm.
for just local control. It provides a kind of a web browser based control for robots on your local Wi-Fi.
Cool.
Yeah, so this is kind of what I have. But right now I'm mostly working with the ESP32 self-balancing whenever I have time. Not getting much further, but yeah, that is what I've been doing. And then yeah, I also have been like doing this. I printed a small gimbal,
Ah, yeah.
SG90 gimbal. Yeah, I have not assembled it yet, but yeah, maybe in a couple of weeks I will have that camera gimbal. So yeah, a lot of architecture things in my head. What to do?
What is interesting with this discovery protocol, and this is where I really totally agree with you, Venkatesh, is that it's a problem that has been around for decades, basically. Okay, really, one of the we talked about web services, what was called web services in the early 2000s. Okay, and that was a daunting problem. I think that's one of the reasons why they just disappeared. Okay, that never pan out because there was a problem with discovering services. And here is really more like a central issue. But on top of that, there is something also super interesting. It's about remote control. Okay, um, and if I'm not mistaken, there are a few people who try to put a word on like a telepresence. Especially like a doctor in America would do some surgery on, in I don't know, in India, let's say, okay, remotely. Okay? There are some systems like that, okay, but the problem is basically the latency, right? Okay, and so what's very interesting with this discovery issue is that this discovery feature is that it's super complementary to that, okay, and at the same time also we may have ideas also on this telepresence kind of features as well. Okay? Over the past few years, there was quite a few startups. I know at least two who get very very high funding here in Japan. Okay, on that particular issue, And both of them disappeared. Okay, but it's not an easy problem, right? And of course, there are direct applications to space, right? Okay.
Yeah, so the question was still like, how do we converge all these different things we are doing, right?
Right. Yeah. Mm.
I think this is the convergence point. Like you're describing the back end of the convergence point, and the various random experiments they can all kind of fit into this uh, discovery layer as the main goal for 2026. Build the discovery layer and demonstrate it with whatever random have a collection of robots we happen to have.
Mhm.
So if we end the year with like 6 random robots in 4 different cities, all available on the YaRG 8004 directory, that I would count as like successful goal.
Yeah. Actually, that is not that difficult. uh, if we have time, yeah. Like all the components already exist. It's just a matter of like connecting them.
But to me, what may take time is to play with it and to see what problems there are,
Yeah.
especially in terms of safety, security, possible. For example, for self-driving cars. Okay, I mean, some self-driving cars technologies are really good. Okay, and basically the problem of these technologies is not tech. Okay, it's more laws and such kind of stuff, right? Okay, and so I'm super curious to see. This discovery allows us, for example, to create. We talked last week about renting a robot maid, okay, to take care of the house, okay. Yeah, but we can, technically speaking, we have all the pieces apparently, right? Okay, but is it
Yeah,
useful?
but like it depends on are we going to productize it or not. Like productizing, it's like
All
more
right.
powerful.
No, sure. Without talking about productization, it's more about having something that allows us to reason and to build,
Mm.
to sharpen our thinking about where this leads, what the problems are going to be. Okay, because even if we don't productize it, okay, I'm doing robots every day. Okay, so I can see myself being in the discussion where people talk about it. Okay,
Okay.
and then it's. I think we can be pretty sharp on such kind of topic. Okay, thanks to real life experience. Okay.
Mm.
And Venkat can find us a client. So,
Yeah.
I think the goal beyond like not productization, but like an intermediate goal to that is a geek level open source thing. Like anybody should be able to go to the YaRG Garage website, maybe download something to set up their own homepage describing their robots and join the YaRG Garage network, something like that, right? So right now we have 4 nodes in this network. If this is set up correctly, then anybody who happens to have a robot and knows enough to put up a simple website with their robot's details available, they can join, and we can create maybe the world's first social network for hobbyist robots. That's if we have this backend available, that becomes possible, right? So that's not a product per se; it's more like an open source project, but then that creates more openings.
the adjacent possibility, right?
Yeah. We have 5 minutes left.
We will create the LinkedIn for robots.
Yeah, it's actually kind of LinkedIn.
Indeed, yeah.
We
Indeed.
can start from the slop part already. We don't have to make it useful. We can just have slop in there.
And then now we need a name.
Chained in.
Plugged in.
Chained in implies that you have a chain, like
Yeah.
a mechanical chain. But today we don't use chains. We use electric motor. So
blockchains.
Yeah.
Anuraj, very interested to contribute. Okay, so
Yeah,
I'm
I'll share that chat and then search for. I'll send you the link to the Chaos Chain SDK. So they were a research group in Nethermind. So Nethermind is a blockchain-based company,
Mhm.
and then they were like a research group inside. And I think like last month they spun off from Nethermind. So I think it's an independent company right now developing that SDK. But yeah, I had so they provide I think TypeScript and Python SDK. If we use Python, then basically we can integrate it to the backend I have been developing. So
Right.
yeah, I'll share this chat and then provide the SDK link, and maybe somebody could have a look inside.
Yeah. Thanks for that. On my side, I will try to flesh out this simulation idea, because it's an idea of some kind of multi-agent simulator with several robots, and
Yeah,
maybe we're using the React web page. I don't know, to just to have this run, easily, basically.
yeah. So
Like-
basically,
like-
then without hardware, we could test it. Yeah.
yeah. Cool. Okay.
Okay. Then see you.
Well, thank you for your time. Talk to you next week.
Okay. Bye.
Yep.